All right, let's talk about continuous integration. So up to this point, the process that we've been using for building, for running our tests, for compiling and packaging, and then deploying over to our GitHub and our Heroku, has mostly or entirely been manual, right? And so instead, we want to go into a process which is as automated as possible, right? Where the developer is free to just focus on really what they're good at, right? Just developing, right? Just focusing on their code, focusing on writing good tests, right? And instead, everything else that runs the tests and compiles them and packages them and checks it in and whatnot, right? All of that should be automated all the way down to delivery, right? So what we're going to be doing is that we're going to be looking at tools and techniques for allowing us to do just that, right? So the concept is called continuous integration, but it includes many different skills. Right? So continuous integration, your Martin Fowler says continuous integration doesn't get rid of bugs, but it does make them dramatically easy to find and remove. Right? Usually one of the things that you want to ask when you go into an interview, make sure that ask what is their process. How easy it is for them to go from somebody writing a piece of code and having it go down all the way to delivery, being delivered as a final product. How easy is it for them to have a brand new feature, right, and make it all the way through into their QA environment, into their test environment, into their production environment, right, and have them explain to you, and maybe have you have also some your own particular views, and you might want to share some of your experiences in continuous integration. There certainly that will be well viewed, that that you are well versed in many of these techniques. So continuous integration. What we want to be able to do is that again, have folks be able to focus on their code, obviously following good practices of working on their own particular branch, right? Creating pull requests for folks to merge, right? But after that, right, after working in their own particular repositories, everything else, right, should be automated, right? Because typically it's you want to make sure that your test, you want to make sure that you want to protect the production environment as much as possible from any inadvertent introductions of bugs that you might have introduced, right? So you want to make sure that tests run, that it's packaged correctly, right, and then it's automatically sent over to the production environment. So from what we're going to start doing from now on is that we're going to start protecting the master branch. Right now, pretty much anybody could merge into the master branch. We're going to start having a little more respect for the master branch. We're going to say, well, the master branch is going to be our source of truth, right? Whatever's in the master branch, presumably, is whatever is actually deployed on production, right? So there should be a reverence to the master branch that you don't just willy-nilly merge into the master branch. Right now, if someone else approved your pull request, it went directly to the master branch, right? Instead, what we're going to start doing is that we're going to stop doing that. We're going to protect the master branch, and instead, we're going to give that responsibility to tools such as Jenkins, that is going to make sure to, whenever you check in something, whenever someone requests the merging to the master branch, it's going to make sure to run all the tests, right? And that if anything fails, right, it's going to push back and say, no, sorry, the tests fail. I'm not going to merge this into the master branch, and it's going to notify. It's going to be logged to see who was the last person, right, who pushed in a pull request, right, that actually would have made the build fail. Okay, so this allows us to have a tracking of an audit trail, right, of what's going on. Ideally, you would test everything locally, and making sure that you have the latest version of the master branch merged into your environment, and you run all your tests locally. Once you are certain that you are not breaking the build, you would then request the pull request. Right? You would generate a pull request, is certain that your code will not break the build. Ideally, whoever you're asking to review this, they too would test it. Would test also in their local machines, and then they would accept your merge request. Jenkins would then run it again, all the tests for you, and if everything passes, it would then exceed to merge it into master branch and then make it build all the way down to production. Okay, right? And so we're gonna be creating all these hooks, all these web hooks that are going to be able to monitor the process as we go forward. Now, usually there are, as in any serious corporation or enterprise application, typically there's several environments that are involved. Typically you have your local development machine right in front of you where you're working, and there could be multiple other environments that before you ever get to deploying something into production, right? Some folks are more granular, some folks are more flat, other folks are much more deeper. But here's a common setup where you have a development environment, and as you develop and you accept something as being completed, this can be automatically packaged and deployed into a test environment, right? Where folks can do some QA, folks can do and try some manual testing, and then if it goes all the way to staging, we refer to this as continuous delivery, meaning that it can automatically accept and merge from the developer and deploy to the test environment, or even down to the next higher level environment called the staging environment, meaning this might be a live machine in the live network that is accessible for beta testing, that folks actual clients can maybe look at right before accepting this, doing a final user acceptance testing, and then finally agreeing for this to go into production. Okay, if your continuous integration, if your continuous delivery process includes all the way down to production, we usually refer to this as continuous deployment. They can take into account all the various stages of the delivery. Okay, lots of benefits. We reduce the integration uncertainty. Right, we typically when you test it locally, you have a local database, you have a local server running on your machine, and hopefully it's as close as possible to the actual machine where this is going to be running, right? But there's always an uncertainty, right? That hey, it's running on my machine. Will it run on the remote server, right? There's always that uncertainty, and oftentimes, we should try and not get into the attitude of, if something goes wrong, have the attitude of saying, well, it works on my machine. I don't know about what that other machine is, what's wrong with that other machine, but it works on my machine. So we want to remove that kind of attitude, in such a way that it's the whole system, right? So we want to make this as continuous as possible, right? That if it works on your machine and you have a continuous integration, it just happens automatically, right? You would if it doesn't work in the remote machine, you would be notifying instantly, right? If you commit something and something is merged, it will be not much further than 5 or 10 minutes that it's running on that remote machine, and you would be notified immediately if it failed, right? So you want to reduce the uncertainty whether that is actually going to work with a remote database, with a remote API, with a remote whatever, right? There's also typically you're working on an environment where it's just locally on your machine, But the remote machine typically has all sorts of other teams working that are still deploying, are also deploying to the same exact machine, right? And you might be team A, B, or C, but you all are deploying to the same stage or the same test machine. Yes. So you want to make sure that, right, if you are pushing something that might block some other team, that you would know it immediately, right? That team B broke the build, right? And then so everybody can jump right away to see what's going on. And there's an audit trail of what exact pull request caused the failure. We can address this early. We have less time debugging. It really creates a solid foundation where we can all build on, and reduces the risk that this is going to make bad code makes it all the way to production. Some of the practices, we're gonna be maintaining a single source repository, which we already are. Now, this doesn't mean that we need to host both the Java and the React on the same repository. We could have independent repositories for those, right? But all the server or all the middle tier is implemented in one single repository. Obviously, there's different stacks that we're using, right? And each stack merits a separate repository, but each layer has its own repository. You automate the builds. We as much as possible we automate all the testing. Every single commit that we make, we run the test locally, right, and make sure that that makes it all the way to the integration machine to see if the integration tests run. We want to keep the build also fast, right? If every time we commit something and the test runs and it takes 5 minutes, folks are just going to be discouraged at committing things frequently, right? We're going to start. Folks are going to be reticent of committing things frequently, right? If it takes 5 to 10 minutes to run the build, right? Instead, we want to make them as fast as possible, run the test quickly, so that we can, every time we commit something, we can know immediately if we broke something right away. Typically, we want to test on a clone environment that is identical to the as much as possible to the production environment. Sometimes this is not possible, since maybe some of the data that is in the production environment might have private information that us as developers should not have access to. There might be credit cards in there. There might be private emails and addresses or phone numbers or account information or balances that we shouldn't have access to. So oftentimes we have a modified version of the production environment where the data has been anonymized, right? But is as close as possible to what the actual production environment is. Oftentimes the production environment is much more robust, much bigger machines with much bigger memory footprint. So it's not always possible to have an identical test environment that is identical to the production environment. But we do want to make sure that we are always testing the very latest, right? And that there needs to be a understanding amongst all the team members and amongst the various teams in the organization that if there was any changes that were merged recently to whatever branch, whatever master yours is built off of, you make sure that to always go fetch the latest master and then you merge into your local feature branch, right? That you're always working with the most recent code in your feature branch, right? You don't want to get too far away from whatever the master branch is. So there's some habits that we want to start. We want to promote. Developers should check out the code into private workspaces. So you have to have your own feature branch. You want to commit changes to the repository. Continuous integration is going to be configured to monitor the repository. They're going to check out all the changes, right? So whenever you commit, the server is going to automatically they're going to check out the master branch. It's going to automatically build this. It's going to automatically run the tests, right, and flag any failures to whoever, whatever build is offensive. If the build fails, the CI server can alert the team. They can be configured to send out a text message or send out a Slack message or an email message, or even call someone during the night that the build failed, right? And somebody should look at this, right? So it can be configured to have all sorts of alerts to make sure that the build is always healthy. The team fixes the build at the earliest opportunity, and we continuously do the testing throughout the project. Things that the team should do, that you should always check in frequently, right? You should not have large number of files that you're checking in. There might be here and there certain times where you do have to do that. Maybe lots of images or lots of documents, static documents or sound files or whatever that you need to check in as one. But typically your logic, your source should be very targeted. Right? You complete a function, some granular functionality that is testable, is enough to be tested. Then you create a commit, right? And not creating large number of functions that in one single commit. That's a bad practice. So you want to check. Don't check in any broken code. Don't check in anything that has been untested. So you should start. Whenever somebody sends you a pull request, you should start pushing back on those pull requests. You should start asking, says, where are the tests? Where is the test that goes along with this function, right? And add your comments to your pull request, and have your fellow developers challenge them, right? Because if you commit something that is broken, it's on you, right? It's now your responsibility. You're saying that you are taking the responsibility of debugging this, right? If whoever broke the build is whoever merged last, right? So we want to spread out the pain and make sure that we all agree that this is the code that we want it to go in, right? Ask for a demo. Ask for jump on a Slack, on a quick Slack message, right? And have the other team folk who's asking you to do the pull request, to demo it for you. It says, hey, look, if I click here and I drag here, it's working. This is the way it's supposed to work. Go through the acceptance tests, right? Make sure that if you go through acceptance, it actually behaves as it's supposed to behave. If the name of the variables are not what you expect, or the name of the functions, or if you find something that it's going to cause later on to come back and fix it later, it's much cheaper to fix it early. It's much more expensive to try and fix it later. All right? Don't go home after checking in until the system builds. If you check in something, stay until you're certain that you didn't break the build, right? Because if you broke it, you need to stay and fix it. All right, so it's very, very important. All right, let's talk about Jenkins.